in this lesson, we are going to talk about coterminal angles. So coterminal angles are angles that share the same terminal side. So remember, a terminal side is where an angle ends. So if we have an angle of 100 degrees, another coterminal angle, meaning an angle that lands on the same terminal side, would be 460, because I could do one full revolution of 360 plus 100. I could also go backwards by 260 degrees to get the same angle. So essentially, all we're doing when we find coterminal angles is we are adding or subtracting multiples of 360 degrees. Or in radians, we're adding or subtracting multiples of 2 pi. So in the first example, it's asking you to state a positive coterminal angle in the first positive revolution. That's what this means. In future questions, you will not be told necessarily the first positive revolution, but if I tell you find a coterminal angle between 0 and 360, or between 0 and 2 pi, you need to know that that's in the first revolution. So if I have an angle of negative 130, I want to find an angle between 0 and 360 degrees. So I'm going to either add or subtract multiples of 360 till I get an angle between 0 and 360. So here, I know if it's negative, I'm going to have to add 360. And when I add 360 degrees, I get an angle of 230, which is between 0 and 360. So negative 130 and positive 230 are coterminal angles. Now, when I'm working in degrees, sometimes it requires a little bit more work. I have an angle here of 8 pi over 3. Remember, that's equivalent, use what you know about fractions. This is equivalent to 2 and 2/3 pi. So it's larger than 2 pi. So if I subtract 2 pi, and in this case, to do that subtraction, I need a common denominator. So I'm going to subtract 6 pi over 3, which is equal to 2 pi. I get 2 pi by 3, which is between 0 and 2 pi. So it's in the first revolution. Now, similarly, in question C, I have negative 5 pi over 2, and it's negative, so I know I need to add a multiple of 2 pi. Now when I add 2 pi, again, using a common denominator, I still get a negative angle. So I need to then add another 2 pi. Because remember, I can add multiples of 360 or 2 pi. So I can add it multiple times. In this case, I get 3 pi over 2. Now here, 19 pi over 3. This is quite a large angle. When I subtract 2 pi, or in this case with a common denominator, 6 pi over 3, I get 13 pi over 3, which is still not in the first revolution, so I need to subtract another 2 pi. Again, I'm still not in the first revolution, but when I subtract a third 2 pi, I am in the first revolution. How do you know whether you're in the first revolution or not? Well, if you look here, 2 pi, one of the first things I did was find 2 pi as an equivalent fraction with a denominator of 3. So 6 pi by 3 is the highest possible radian measure to be in the first revolution. So here, 7 pi by 3, I know is greater than that, so I'm not in the first revolution. So once I get under 7 pi by 3, then I know I'm in the first revolution. Now, we also can look for multiple coterminal angles. So in example 2, it says state all the coterminal angles from negative 360 to 720, or negative 2 pi to 4 pi. This means within the first 3 revolutions. So if I have an angle of 220, that's between 0 and 360. I need to subtract 360 to get the first negative angle, and I can add 360 to get the angle in the second revolution. Same for in radians. This negative 5 pi by 3, that's in the first negative revolution, because remember here, 6 pi by 3 is equivalent to 2 pi. So negative 6 pi by 3 would be the greatest negative revolution here, up to, if you wanted to set your parameters, I'm going between negative 6 pi by 3 up to 12 pi by 3. Those are the parameters that I'm looking for. So I can add 2 pi to get pi by 3 and add another 2 pi to get 7 pi by 3. So I've got the first negative revolution, the first revolution, and the second revolution, all those coterminal angles. And C and D are very similar. So here, 4 pi by 3, again, if you wanted to set up your restrictions here on your domain, we're over 3. So again, actually, it's the same as the previous one. So 4 pi by 3 is in the first revolution. When I add 2 pi, I get 10 pi over 3, which would be in the second revolution. And when I subtract, I get negative 2 pi over 3, which is between 0 and negative 6 pi by 3. Now in question D, it's exactly the same, but in this case, when I do my first subtraction of 19 pi by 3, I get 13 pi by 3, which is not small enough. This would be in the third revolution. So I need to subtract 2 pi again to get 7 pi by 3, which is in the second revolution. Then I subtract again to get pi by 3, which is in the first revolution. And then I subtract again to get negative 5 pi by 3, which would be in the first negative revolution. So those are all coterminal angles. Now we can also state, what you might notice here is you could keep adding and subtracting these multiples of 360 or of 2 pi, and you can get an infinite number of answers. So anytime I have an angle, there's actually an infinite number of coterminal angles. And when we state all of those, we call that the general form. So in a general form, here we have the angle plus or minus 360 times k, or the angle plus or minus 2 pi times k. And k is the set of all the integers, plus or minus 1, plus or minus 2, plus or minus 3. And what this means is I can add or subtract all of the multiples of 360, either positive or negative. And I write this when I'm writing in general form. Now here, I actually don't need this subtraction here, because technically, k can be positive or negative. So if I was multiplying by negative 1 or negative 2, that's the same as subtracting. So you can actually just write the general form as plus 360 times k, as long as you say that k is integers, so positive or negative. So if you wanted to state any of these angles that we had up here in general form, all that you would state is that you have 220 degrees plus 360k. So k could be any multiple of 360, where KEZ, Z is the symbol for integers, meaning either positive or negative. Same thing when it's in radians. You would say negative 5 pi over 3 plus 2 pi k, where k can be any integer. And the same for C and D, plus 2 pi k, where k is any integer. And that just means you're adding multiples of 2 pi or multiples of 360. And those multiples can be positive or negative. So try out the practice questions in your textbook to get used to these coterminal angles.